Hi guys, this is already the third chapter of economic statistics. The third chapter, the title is Measures of Location, but you may not be familiar with what it means, but actually its meaning is pretty simple. So in the previous two chapters, we learned probability, and the meaning of the title of this chapter is the average. So average will be viewed as a measure of location of the data. So in this chapter, we are going to learn the average and some of its alternatives and variants. So basically, you get the idea, right? So we are understanding average as a way of describing the location of the data. Okay. So in the end, we learned probability and the average. These are just simply two most common methods to summarize and describe data, right? So even if you learn more advanced techniques, roughly speaking, all the statistics techniques are basically some combinations and variants of probability and mean, probability and averaging. So these are so important, and actually exactly the average you know. So we are going to review the definition, the structure, and what we need to think about when we calculate or define an average. So the relevant textbook chapters are given. Simply search for average, then you will see a lot of information like online or from textbook. So let me start with a simple brainstorming question. So suppose that we are interested in used cars market, and we collected data on, say, these variables. First, listed price and the make and the model of the used car on the market, and the model year, the mileage on the used car, and the number of major repairs on the used car's record. So you study what kind of used cars are available on the market, and so you collect data. And the first thing maybe you want to do is to calculate the average, just to see how the market is formed. By the way, but one of the variables do not allow average. What is it? Think about that. The answer is B, make and model. So the main difference here is like price, model year, mileage, number of major repairs. Those are numbers. But make and model, like Toyota Camry, so Ford, Chevrolet, like these kind of things are not numbers. So you cannot calculate the average, right? So this is maybe the first important requirement to study the average, right? So to calculate the average, the variable must be a number. And as I said, the make and model is not a number. In this case, we call the variable as categorical or qualitative. So it's like, so later we are going to study more about this kind of non-number, non-numerical variable in chapter 5, say. But so the other variables are numerical, quantitative variables. And then once you have a number, and numbers, there are a lot of things you can do. You can add, you can like compare them, which is larger or not. So a lot of measures are based on numerical variables, right? So average, maximum and minimum, and variance, standard deviation, and median, percentiles. So like these measures, important, famous, popular measures, require the variable to be a number, right? For example, if you think about, again, make and model of a used car, like Toyota Camry, how can you think about what is the average between Toyota Camry and Honda Accord or Tesla Model X? So how do you calculate the average? What is the maximum? What is the variance? So there is no such measure if you don't have numerical variables. So the first thing I'd like to fix here is that we are going to define a random variable. Say a random variable is a numerical description of outcomes from an experiment. For example, if you think about coin toss, the outcome is either heads or tails. So basically, it's not a number. Heads and tails cannot be added, cannot be compared, which is greater. So they are not numbers. But if you describe them using a number, say for example, 0 stands for heads, 1 stands for tails, then this becomes a random variable, right? So you have to transform non-numeric descriptions into numbers. It's like kind of encoding, right? So attach code. Like similarly, if you think about like car makers, say number them, like say 0 stands for Tesla, 1 stands for Toyota, like 2 stands for Ford, like that. If you attach number for each like outcome, then you get a random variable, right? So we call that numerical description as a random variable. In most cases, the numerical description of the outcome is pretty natural, like dice roll. When you roll a dice, you get a number. Then that is just a random variable. You may use it as directly as a random variable, or otherwise you may change it. It doesn't matter. So instead of saying 1, 2, 3, 4, 5, 6, you may call them 10, 20, 30, 40, 50, like that. So not a problem at all. And similarly, like YouTube video count, right? So then the outcome is non-negative numbers, non-negative integers. So if you randomly choose a YouTube video and see how much view counts it has, then that's a natural number. That is a number. And stock return, if you're interested in randomly chosen stocks or random days stock return rate, then also its outcome is automatically a number. So a lot of random experiments have numerical outcomes, then there is no concern. But if not, then you need to encode the outcome as a number first, and then you may use those numerical measures. Okay, that's basic things I'd like to fix first. And here, more notation. Once you have random variables, that means once we assume that the outcome from a random experiment is a number, then we can define more mathematical notations because we know it's a number. So I'm going to write the random variable as capital letter X or Y or Z. So when I need 2 variables, X and Y, and 3 variables, then X, Y, Z, 4, then X, Y, Z, maybe W, like that. So typically capital letter notation stands for random variable. So for example, I'm going to write probability this way. This is the probability that a random variable X equals to a certain specific value. So in this case, this lowercase letter x is actually not random. So for example, think about this. If you think about the probability that the number on the dice equals 6, for example, it's a complete sentence, good sentence. And then in this sentence, you know what is probability, but inside the probability, we have 2 things. We are equalizing 2 things. One is the number on the dice, which is the random variable, the random outcome after rolling a dice, right? So this is one thing. And on the other side of the equality, we have a number 6. This number 6 is not random. We just happen to be interested in number 6, right? So similarly, you can think about probability of even number, probability of a number greater than 4, for example. So then in these kind of probabilities, this is just an event of interest, not a result of the random experiment. Of course, so it restricts the event that we are interested in, the outcomes that we are interested in, but it is not random. It is just it represents your interest. I am interested in 6, but it does not change. So even if you repeat an experiment, this number does not change. So we are going to use lowercase letters to denote such a specific value. So I'd like to distinguish that X capital letter, uppercase letters are random variables. So it is unrealized, it is random. So if you try the experiment again, the capital letter X can change, right? However, the lowercase letter is about your interest, what you would like to know, right? So it's not random, it is your interest, and it is a specific value or specific event. So we denote that using lowercase letters. And also you may use inequality, right? Greater, smaller than or equal to y. By the way, so it is cumbersome to say probability that y is smaller than or equal to lowercase y. So often I'm just going to call this smaller than uppercase y smaller than lowercase y. So ignoring the equality, just out of laziness. So please understand, it's not that important, like in this course. So when it is important, I'm going to tell you, but otherwise I may just say quickly as uppercase y is smaller than lowercase y. Okay, and even if I become even more lazy and like for simplicity of the notation, when it is obvious, I suppress the random variable we are interested in. So often in many cases, I define a random variable, so it is clear what is the random variable we are talking about. Then I just need to specify the event that we would like to calculate the probability. So I may write it this way. So it means what's hidden is random variable x, uppercase letter. And lastly, so when you define a random variable x, and then if you actually repeat the experiment, then you are going to observe certain number of data that will be denoted as subscript x1, x2, x3. So x subscript 1 is the result from the first experiment, and x subscript 2 is result from the second experiment, blah blah blah. And as usual, n stands for the sample size, which is the number of repeated experiments. Okay, so notation is not that difficult, intuitive way to define the notation. Let me start with an example, simple example. Assume that there are only 2 students, or there are 2 students, and I can give A to one of them, but I had to give like a B to the other students, say, for example. So I have 2 students' performance records from a class. Suppose student 1 had 90 points in homework, 70 points in midterm, and 80 points in final exam, out of 100 each. And student 2 is worse in homework, but better in midterm and final. Okay? So in this case, I need to compare these 2 students but there are 3 dimensions to compare them. Like for example, if I look at homework, student 1 is better, but midterm and final, student 2 is better. On the other hand, you may put it this way. So homework, student 1 did much better than student 2 in homework, like plus 20 points. but the dominance of student 2 in midterm and final is only plus 10, plus 10, plus 10. So in that sense, depending on your perspective, the decision can be different. There is no like unanimous decision in this case. You just have to find a simple number so that you can make the decision. So the main reason why we cannot make the decision clearly is because there are 3 numbers for each student. We have to summarize the data, the observations into one number so that we can compare which is greater, right? The idea is clear. Like what we need is a weight. Like, yeah, look at the syllabus, like not this course, I mean. Like suppose that according to the syllabus, homework takes 20% and midterm is 30% and final is 50%. Then according to these weights, you can calculate, you can summarize 3 numbers into a weighted total. And then based on this ratio, based on this proportion of grades, student 2 is better, got a higher grade than student 1 overall, right? Because exams receive more weights than the homework, so student 2 did better in exam, so student 2 will get a better grade, right? This is a simple way to make a decision, to compare, to choose which is better, right? Who is better, right? We are going to use this idea and study the average. So in general, measures of central location, like measures of central location or measures of central tendency of data, is a value around which the data are located or centered. That is definition. So in this example, our weighted total implies that student 1's grade distributions are around 79 using these weights, and student 2 is around 83. So they are a typical or representative outcome, right? That's the purpose of a measure of central location, right? We would like to represent a student with only one number. And then if you have the central measure of central location, then it enables you to compare between multiple numbers. Like here, 3 numbers versus 3 numbers. But in the end, you reduce them into 1 numbers. So then you can make easy comparison. So it helps in the end. The reason why we need a measure of central location is because it helps you make decisions more easily, and it's more transparent, and you can think about the weights, so it will be easy to understand why one is concluded as a better option than the other. So that's what we are going to do. How we are going to understand on average. So, and examples, there are many examples of measures of location, but in this class, in this course, we are going to study 2 measures, mean and median, right? So that's our overview. Like it's the overview of this chapter and the motivation of this chapter. So I'm going to stop this video here, and in the next video, I'm going to define what is the average, what is the mean. Okay? See you there. Bye.